Good morning, everyone. I hope you all are having a wonderful day. Again, I also want to start with some quick apologies here. Not too sure what happened to that video file. I think now I just need to start uploading everything to YouTube instead of trying to just upload videos. This is now the second time this has happened. Not too sure why, but oh well, we'll do it again. No big deal. Today's lesson is talking about solving equations with fractions. Now, you know how to do every step, and we just keep adding one more every time. Like we started with questions like this, 2x equals 4, and we learned how to solve those. Okay, then we did two-step equations where we had 2x minus 4 equals 8, and you guys learned, we'll move this over first, and then we'll divide by 2. Then we got questions that we did, let's say 2x minus 4 equals 4x minus 3, where we had variables on both sides. All right, so this is kind of like our progression. And then after that, we did questions where we had brackets. And we solved questions that looked like this. Okay, and we've just kept adding one step every time. And today's the last step that we're going to add. Today we're going to be talking about fractions inside of our equations. Now, when we solve regular questions, I always say fractions are the best. We want to keep them. But that's when we're comparing either a fraction answer versus a decimal answer. Now, when we're doing solving equations, we do not want to work with fractions. We want to work with whole numbers and integers. So, the first step, if we ever see a fraction in our equation, it's how can we get rid of this fraction? Okay, that's our first step. And if we're looking here in the first question, we have x divided by 5, or x over 5 equals 4. Now, it says here, clear the fractions by multiplying all terms by a common denominator. This should say, instead of a common denominator, it should use the lowest, I like this term, lowest common multiple. You may have used that term in elementary school, LCM. Okay, and what the lowest common multiple is the smallest number that all the denominators will go into. But in this first question, we only have one. We only have a 5. So the way to get rid of the 5 on the bottom would be to multiply by 5. So if you have 5, x over 5 is equal to 5 times 4. If you can see, we've multiplied everything here by 5. The question isn't any different. Like if we have this, 2x equals 10 is the same. If we multiply everything by 5, that would become 10x equals 50. Okay, both questions are the same because x equals 5 for both. 2 times 5 equals 10, and 10 times 5 equals 50. Because whatever we multiply to the left side, we multiply to the right, the equation doesn't change. Okay, it's still equal to each other. But the reason we do this, if you see now in this question, we've now canceled out those 5's, which now means we no longer have a fraction. The left side is just x, and x is now equal to 20. And there we go. Beautiful. Okay? And that's what we're going to be working with today. So now let's look at the second one. Now we have two fractions. Okay? We have now a denominator of 5 and a denominator of 3. We have to figure out what can we multiply the entire equation by to make sure we no longer have fractions. So what I would recommend you doing if you can't figure out the lowest common multiple in your head is you just write some of the multiples of 3. So 3, 6, 9, 12, 15, 18, let's say 21. There's a bunch. And then I'll write down the multiples of 5. 5, 10, 15, 20, 25. And you try to find the first matching pair. So I noticed that the lowest common multiple between 3 and 5 is 15. That is the lowest common multiple. So now what I'm going to do is I just need to multiply the entire equation by 15. Okay. So let's give it a try. So we'll do 15 times the first term, which is 1 over 5x. And instead of writing 1 over 5x, I think I'd rather just write that as x over 5, because that means the same thing. Minus 15 times 2 is equal to 15. I'm going to write this as x over 3. So as you can see, all three terms are now being multiplied by 15. So from here, what I would recommend, okay, is I like to do this next part in one step. You can do it in 2 steps, okay, but you eventually this should be a 1-step transition. And how I do this, when I have a constant multiplied by a fraction, if possible, I always do the division first, and then I multiply to the top. So what I mean by that is 15 divided by 5 is 3, and 3 times x is just 3x. The next term is just 15 times 2, which is 30. And same thing with here. We'll have 15 divided by 3, which is 5, times x, which is 5x. Okay. The reason why I like to divide first before I multiply is because it keeps the number nice and small. Okay. If I gave you this, let's say 15, and you had, let's say, 5x over 3. If you multiplied this by 5, which you can, okay, if you do 15 times 5, then we have 75 over 3x. That isn't easy to do that in your head. 75 divided by 3. Not so easy. But if you do it the other way around, okay, if we divide this first, the 15 and the 3, we go, oh, that's 5, and then 5x. That is a lot easier to solve. You could go, that's 25x. To me, that's an easier progression than trying to figure out how many times did 3 go into 75, which is also the same answer, but not as easy to find. Okay, so that's how I'm going to do it for every question. You can do it whatever way you prefer, but just giving you a heads up, every question I do, that's the way I'm going to do it. So now from here, we're almost done. We just need to solve. So I'm going to pick up the 3x, move it to the other side. So now we have negative 30 is equal to 5x minus 3x. So then negative 30 equals 2x. We'll divide both sides by 2 and get a final answer of negative 15 equals x. All right, so now we're off to question C. Now, we have 3 fractions in this question. Okay, same exact mentality. We have a 3 on the bottom, a 2 on the bottom, and a 6. Those are our denominators. And again, you have to go, what is the lowest common multiple? Okay, and again, if you pick something bigger, it will still work. It'll just be harder to work with, okay? So I know the multiples of 2, 4, 6, 8, 10, 12, 14, 16. There's a bunch. 3 goes 3, 6, 9, 12, 15, 18, 21. And 6, 12, 18, 24. Hopefully you guys can see in all 3 of them, the lowest common multiple is 6. So that means we have to multiply the entire equation by 6. All right, so this will be now 6 x over 3 minus 6 3x over 2 equals 6 1 over 6 minus 6 times x. All right, everything's being multiplied by 6. Now let's solve. So again, doing the same thing, divide first, then multiply to the top. So 6 divided by 3 is 2, so this will be 2x minus 6 divided by 2 is 3, and 3 times 3 would be 9x. Now that will be equal to, and again, I shouldn't put an equal sign there. I should only have one equal sign for every line of math. There we go. Now 6 divided by 6 is just 1 minus 6x. Okay, now look how much nicer this equation looks versus what we started with. They are identical. They mean the exact same thing, except for now we've removed all of our fractions. All right, this should be a lot better to work with. Now let's solve. What I'm going to do is I'm going to move the 6x to the left, and then solve. So this will be 2x minus 9x plus 6x is equal to 1. Now, 2x plus 6x is 8x minus 9, so we'll have negative x is equal to positive 1. And that must mean then that positive x equals negative 1, equals the opposite. And again, if you're not sure how, remember negative x means negative 1x equals 1. If I divide out by negative 1, then you can see obviously why x has to be negative 1. Okay, same thing, just showing you where I got the answer. All right, and now we're on to the last one. On the next page, we're going to start checking our work to make sure we're doing it right. But let's just finish up this example here so we're a little bit more comfortable with the process. So again, we're looking at the bottoms. We have a 5 and a 3 as our denominators. Okay. Now, we've already done that. We had 5 and 3 as our denominators in the above question. So we already know we just multiply by 15. Okay. Again, if you multiplied by 30, it would work. It just would make the numbers twice as big, okay, which we don't want. So let's give this a try. We'll have 15, 4k divided by 5, minus 15 times 4 equals 15 times, k over 3. All right. Again, same process. We'll do 15 divided by 5 here, which is 3, and 3 times 4k is 12k, minus 15 times 4, 60. And the last one, we have 15 times k over 3. We'll do that division. 15 divided by 3 is 5, so this will be 5k. Again, looking from where we started to where we got, way nicer to work with. And now from here, I'm going to pick up that 12k and move it to the other side. So negative 60 equals 5k. Oh, I have to write the answer. Minus 12k. So negative 60 is equal to negative 7k. And now when we divide both sides by negative 7, we get, well, just 60 over 7 is equal to k. Okay, I know not a lot of you are probably looking at that answer like 60 over 7. Like, are you sure that's right? Okay. That is the answer. I'm 100% sure. And we can always check the answer if we want. Okay. And I'm going to show you how to do that in the next couple examples. I don't want to start checking the answer with a one like this because this is kind of tough. Okay. So let's look at these examples. Okay, the first one will be a little bit easier. The second one will be a tough one. Okay. So again, we have two fractions. First step is always the same. We need to figure out how to get rid of them. Now, our denominators are 3 and 9. Again, 3's multiples are 3, 6, 9, 12. 9 would be 9, 18, 27, 36. Hopefully right off the bat you're noticing, well, 3 goes into 9. So 9 is going to be our lowest common multiple. Okay? So we have to multiply the entire equation by 9. Okay? So let's give this a try. And we'll have 9 bracket x minus 6 over 3 equals 9 times x plus 8 over 9. All right, there we go. Started it off. And now we can look at the 9 and the 3. All right, I noticed that 9 divided by 3 is 3. I'm going to do this one in 2 steps. So 9 divided by 3, this will be 3 x minus 6, because now we have brackets, so this will be a little bit harder to expand out. And on the right, well, the 9's cancel, and we're just left with x plus 8. Again, look where we started. Look where our equation is now. So much nicer. And from here, we'll just have to distribute our 3. We'll get 3x minus 18 is equal to x plus 8. And now we just need to solve. I'm going to move the x to the left and the negative 18 to the right. This leaves me with 3x minus x is equal to 8 plus 18. This leaves me with 2x has to be equal to 26, or x is equal to 13. Now that I have that answer, let's do a left side, right side check. Okay? Let's make sure that we're doing this right. Here's the left side. Here's the right side. So let's start with just the left side. The left side was equal to x minus 6 over 3. Now let's put our answer of 13 in and see what happens. We'll get 13 minus 6 over 3, which is equal to just 7 over 3. And that's as far as we can go. Again, if you really want, you can rewrite this as 2 and 1/3, but it means the same thing. Okay, either or works. Now on the right side, our equation was x plus 8 divided by 9. So that's 13 plus 8 divided by 9, which is equal to 21 over 9. And now, again, we just need to reduce that by dividing by 3. And that ends up being 7 over 3, or 2 1/3, which is the same answer. Meaning the left side has to equal the right side, and we know we did it right. Okay, so that check wasn't too bad. The next one, okay, is a little bit more difficult. Okay, this is probably the hardest question out of all the ones we've done so far. So let's take a peek here. The first step is the same. Once we realize we have a fraction in our equation, our mind instantly should go to, we don't like fractions, okay, in equations. We need to get rid of them if possible. So our denominators are 4 and 6. So I start writing some multiples of 4 out. I'll start writing the multiples of 6 out, and hopefully I realize right off the bat, they both share 12 as a multiple. That is the number we're going to multiply here by 12. All right, let's see what happens. This will be 12 times 5x minus 2 over 6 minus 12 times x plus 3 over 4 equals 1 times 12. So I'm just going to write it as, well, 12 times 1. Okay? So again, I'm going to do the division step first, and we'll multiply after that. Okay? Again, you'll see why. I guess I'll show you here why. So I'm going to divide them. So this is going to be 2. 5x minus 2. 12 divided by 4 is 3. X plus 3 equals to 12. Okay, that's what your line looks when you divide first. Okay, if I decided to multiply first, look how big the numbers get. Okay. Again, you don't have to do it the way I'm telling you to, but this is why I highly recommend it. If I multiply the 12 into the brackets first, and then let's say you want to divide second, this is what your first line would look like. You would get 60. You'll get 60x. Okay, minus 24 over 6 minus 12x plus 36 over 4. Now look at the difference between this line and this line. Okay, to me this one is so much nicer to work with. The numbers are nice and small, nothing's too big, okay? Which is why you should divide first every time, okay? Just thought I'd go over that. You can do it the way I just had it, but I would not recommend it. Oh, get rid of all this. All right, so keep on going with where we were. I gotta charge this soon. We have 2, 5x minus 2 minus 3, x plus 3 equals 12. Let's expand these out. We'll get 10x minus 4 minus, now remember, this minus 3 is attached. So when we multiply this through, remember, it's negative 3. So this will be minus 3x minus 9 equals 12. Now we just need to collect like terms and solve. So we have the 10x and the negative 3x on the left. That just means we have to move the negative 4 and the negative 9 to the other side. This leaves us with 10x minus 3x is equal to 12 plus 4 plus 9. Or 7x is equal to 25. And now we can just divide out by 7, leaving us with x is equal to 25 over 7. Now 25 over 7 is not a nice fraction, okay? It's kind of gross. But that is our answer. Well, how do we check if our answer is a fraction and the equations have fractions in them? How do we do this, okay? So I'm going to show you how I would approach this question to check. Okay, it is not easy per se, and I'm going to make sure I leave myself lots of room on the left side. There's nothing to check on the right side because it just equals 1. So we have to make sure that our left side matches the right side. So here was our original left side. It was 5x minus 2 over 6 minus x plus 3 over 4. Okay, that was the original equation. Now, and we know that x is equal to 25 over 7. We could substitute the x in right off the bat, but I'm thinking if I put the x in right now, I'm going to have a fraction within a fraction, and I do not want that. So the first thing I'm going to do is I'm going to try to connect or combine these two terms into one fraction, okay? And by doing this, it's just like if we had 1 over 4 plus 1/3. To add these, we would need a common denominator. The same thing with this question here is we're going to need a common denominator, okay? So the common denominator here between 4 and 6 is 24, or not 24, oops, is 12. So I need to have two fractions, okay, but now that their common denominator is 12, so I can't subtract them. So the fraction on the left, originally the denominator was 6. If I want to make that denominator 12, I'm going to have to times it by 2. So the whole top, I'll multiply by 2, so it'll be 2, 5x minus 2. And on the right side, the denominator went from 4 to 12, so it'll be multiplied by 3. So now I need to multiply the top by 3. Now let's kind of simplify that out, and then we'll collect terms. So this will be 10x minus 4. And I'm going to write it all over the same denominator because it's all over 12. Okay, so we have 10x minus 4 minus, and then remember this negative is attached to that 3. So minus 3x minus 9. All right, so now let's collect our like terms. This leaves us with 7x minus 13 over 12. Now I only have one fraction. Now I'm going to put in the x equals 25 over 7. Okay, you can put it in right from the start if you want, and you're going to see how gross it gets really quick. So I would not advise you to do that. This is the way that I would say. Now let's see what happens. We get 7, 25 over 7. That looks nice. Minus 13 over 12. The reason why I say that's nice is now look at this. I can cancel out those 7s, and that leaves me with this fraction. 25 minus 13 divided by 12. That's equal to 12 divided by 12, which is equal to 1. And look at that. Right side equals 1. The left side equals 1. Left side equals right side. I know that was like kind of weird and wacky. I'm not too worried about checks that are that difficult. If we can get our answers, that is the main thing we're aiming for in this unit. We're going to work more with fractions and equations in our next unit, Unit 4. On Wednesday, it will be our review day, and I'm not going to post any other lessons for the week other than Wednesday. It'll be the last day I post something. Then you have Wednesday, Thursday, Friday to do that review, and we will start Unit 4 fresh on Monday next week. Again, sorry for the late upload. Not too sure what happened with the last video. Hopefully this one works out. Again, if you have any questions, please let me know. Wish you guys all